All right, students, today we're going to be graphing the cosine curve, and what I really want to try and drive home is how similar it is to the sine curve and how similar our methods, at least the ones we follow for our book, are going to be. So I'm going to go back to a question, this one. I know this is sine, but the whole thing is, if this was, since this was sine, the graph would look like that. Well, if we change that to y equals cosine of 1/4 x minus pi over 2, that graph would start high and end high. That's supposed to be a little more symmetric than it is. Let's see if we can make that again. Start high, end high. And it looks just like if you chop this off right here and went to right here. It would end up getting high again. So that's the same thing. Start and end will be high and high. Over here, start and end for sine was 0 and it finished at 0. Okay, so let's go ahead and graph that cosine graph. All right, so here's our graph. Here's our equation. Okay, and the method's going to be the same as it was before. We got to find a new start and a new end. Okay, and we do that by setting it equal to 0 and 2 pi. And again, that's because it takes one full revolution around the unit circle to do a cycle of pi. One full revolution is one cycle, and it started from 0 and it would finish by 2 pi. We've got a multiplier in here and we've got a shift of it, so putting both those things together, that will change our start and our end, and this is how we solve it. So the goal here, ignore the fact that it's a pi over 2, it's just the same idea, get x alone, so add this to both sides. It's just like we did in Algebra 1. Okay, now 1/4 x equals pi over 2. Be careful right here. A lot of people will end up going and saying, okay, let's just multiply both sides by 1/4. You don't want to multiply by 1/4. You want to multiply by the reciprocal. 1/4 will not cancel this. 4 over 1 will, because 4 and 4, you'll get 4 over 4x. Over here, you get 4 pi over 2. So we get x, whoops, equals 2 pi. That's our key starting point. Keep that memorized. All right, come back over here. Plus pi over 2, plus pi over 2. Cancels right there, and again, we have 1/4 x. But this time we can't add these as they are. It's 2 pi plus pi over 2. Okay, so let's make 2 pi over into a fraction by putting it over 1. And then if we multiply the top and the bottom by 2, you can get 4 over 2, because 4 over 2 is the same as 2, plus pi over 2. And we needed that common denominator, so we can add these. So 4 over 2 plus, this is again 1 pi over 2, so 4 pi plus 1 pi is 5 pi over 2. And continuing. It's a lot of steps here, so use scratch paper, give yourself plenty of room so you don't make mistakes. Reciprocal, reciprocal. We'll get x here because we'll have 4 over 4, and we'll have 20 over 2, 20 pi over 2. So x equals 10 pi. So from 2 pi to 10 pi, that's our cycle. That's our start, that's our end. Okay. Now, I'm going to need a new sheet of paper, but we'll keep those two numbers in mind. Okay, and what we'll do is go just like this. Okay, so there's our x-axis, and then the curve is going to go down and up. Okay, and that's one cycle of sine. Sorry, cosine. This is 2 pi, and that is 10 pi. That's what we solved for just a moment ago. Okay, so actually this one started out with a fraction, but it's going to be easier. The middle of 2 and 10, the midpoint would be 2 plus 10 divided by 2. 2 plus 10 is 12, divided by 2 is 6. So the middle here is 6 pi. Okay, same thing here. 6 plus 10 is 16, divided by 2 is 8. So the middle should be 8 pi. And 2 and 6, the midpoint would be 4. Okay. One other thing I want to illustrate with this before we wrap it all up. This one's easy to see. The distance between here and here is from 2 to 4 is 2 pi. The next interval is 2 pi. The next interval is 2 pi. The next interval is 2 pi. That's the symmetry we're talking about. Each one of these, from here to here, it has left and right symmetry. It has reflectional symmetry. Okay, and then intervals-wise, each one of these intervals is the same amount of spacing. Okay, so hopefully that helps. Maybe it helps with your drawing. You don't need to put all these ugly dash lines. That was just sort of show you that this part is the same distance as this part, the same as this, as this, as this. Okay, over and over and over again. All right, I hope this helps. Thanks for watching.